All right. Let's try what's called a Charles Law problem. Let's try a Charles Law problem. It's really the same thing, same problem, it's just you have different variables missing. But what Charles said was as temperature increases, volume increases. Okay? So let's check it. So if we start with a temperature of 0 degrees Celsius, basically we're trying to freeze some water or something like that, water vapor, cool it off, and our V1 equals 5 milliliters. Our new temperature is 100 degrees Celsius. We're heating it up, and V2 is equal to what? Okay? Now, for this to be water, if it was water, we would have some moles and some pressure considerations for it to still be a gas at 0. Because you can have water as a gas at 0 degrees Celsius. Okay? Alright, which we'll get into in a future unit. First thing, we got our givens. What else do I need to do? Are these in Kelvin, liters in Kelvin? No, so we got to convert. 273.15. Right, because you got to add 273. And this one, King Henry died while drinking chocolate milk. We're at milliliters. Going to our base unit, liters, 1, 2, 3. 1, 2, 3. We're dividing by 10 each step. Moving the decimal is the shortcut. All things we've learned in the past. So now we've got our units converted. Oh, don't forget to label them. So givens, yes. Unknown, yes. Equation. Now, what's missing? What do we not have? Do we have moles? And if the word problem doesn't even mention moles, or says the moles don't change, you can cross it out. What else do we not need? We don't need pressure. And there you go. So now we just substitute. I would keep working it down on my piece of paper, okay? So V1 is 0.005. T1 is 273.15 equals V2 over T2, 373.15. Now what are we going to do? Now let's go ahead and do our calculation. Let's go ahead and start solving. 0.005 divided by 273.15 equals, your calculator may give you something weird depending on the mode you're in. Okay, so now we're going to multiply both sides. And you should get V2, that cancels to 1. V2 equals 0.007. And that's a volume, so that's going to be in liters. Now, let's double check. Did the temperature increase? Yes. Did the volume increase? And that is correct. All right. So you'll have a couple problems like this to try, and then I'll go through the next version here in just a few minutes.